here we're looking at naming organic molecules based on a formula. We're going to run through an example here where we determine the name of C6H12. So our first step is we want to determine what prefix we need to use, and remember that that's based on the number of carbon atoms. So here we have our list, and we see we have C6H12. So we're going to use that 6, and that means we're going to have hex as our base number. So we've already got part of the name picked out, but that's kind of the easy part. So in step 2, we're going to use the degree of unsaturation equation, and that's going to tell us how many pi bonds and rings we have. And that's kind of important because it kind of is tricky to figure it out without doing this. It just requires a lot of drawing. So the degree of unsaturation equation is the number of carbon atoms minus the number of hydrogen atoms divided by 2 minus the number of halogen atoms divided by 2 plus the number of nitrogen atoms divided by 2 and then plus 1. So let's just make a note that X equals the number of halogen atoms. So that's like fluorine, chlorine, bromine, anything in that group. So for ours, we're going to plug it in. Our degree of unsaturation is going to equal the number of carbon atoms. So we already said that was 6, minus the number of hydrogen, which was 12, divided by 2. And then we have no halogen atoms or nitrogen. So then we just add plus 1, and that gives us a total of 1. So we have 1 degree of unsaturation. So that tells us that we have 1 pi bond or 1 ring. And a pi bond is like a double bond. A triple bond has 2 pi bonds in it. So now we're going to draw our structure so each carbon has 4 bonds. And since we only have 6 carbon, we're going to first try this as a linear chain. And if that doesn't work out, we might try the ring. So we have 1, 2, 3, 4, 5, 6. And we said we have 1 degree of unsaturation. So we're going to make one of these a double bond, because that takes care of that degree of unsaturation. Now we have to add back our hydrogen so that each of the carbons have 4 bonds. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, okay. One mistake here. This is why it's good to draw it out, because then you can catch yourself. So, we can see here that we do have 12 hydrogen and we have 6 carbon, and it works out so that all the carbons have 4 bonds around them, which is their stable state. So now that we have the structure, we can determine the name from that. And we want to remember that double bonds, we're going to use the -ene suffix, and that's the one we're going to use today because we only just have 1 double bond. So we're going to put our prefix down, which was the hex, add our suffix, and then we're done. And just as a note, if we did have a different thing, if we had multiple double bonds, we would use these prefixes to the suffix. So it would be like diene if you had 2 double bonds, triene if you had 3, or like tetraene if you had 4. There's more than that, but this will be sufficient for most stuff you'll probably do. The same if you had like ines for triple bonds, diene, triene. So yeah. And hopefully this helps out.